Stoichiometry is the next logical step in what we've been doing. It's also the last step in what we've been doing because at the end of stoichiometry, we're going to be hit and miss different topics in chemistry. We're not really going to be building like we were up to this point. You are going to use stuff from pretty much every chapter from the beginning of the year in this chapter. Step one in stoichiometry problem is going to be what you did last chapter, writing a correct balanced equation. That's going to be only the first step. Then you're going to have to do stuff beyond that. Because here's what stoichiometry involves. Basically, here's your book definition, then I'll explain what it really means. Stoichiometry describes the mass and mole relationships in a chemical reaction. Now, what that means, I will explain after you copy that down. Okay? Because it is actually useful. Not necessarily to you, but to a chemist and to a pharmacist, to someone who's actually doing chemistry. It matters. You know, last chapter, we learned how to predict what was produced from a reaction. You know, we used a common ion sheet. If I told you you had potassium chlorate decomposing, you looked it up in the common ion sheet. You saw, okay, metallic chlorate yield metallic chlorides plus oxygen. And then you filled it in, right, the correct formulas, balanced it, and did all that stuff. Remember diatomic elements, all that stuff. So you were able to tell me what was produced. And that's useful. But if I'm going to work as a chemist or as a pharmacist, I don't have to know just what's produced. I got to know how much. I don't just throw two things together. I'm glad he's wearing his little Breaking Bad shirt there. What was what was his name? Walter White. Walter White is the Breaking Bad chemist, high school chemist that cooks meth. And why was this stuff so popular?
Because it was really pure.
It was really pure. You don't get good results by just throwing things together, and that's what meth heads are going to do. You know, you have to have you have to be able to predict exact amounts you're going to need to get the finished product. You can't just throw them out. That's not how forget about your meth. That's not how your meth is made. It's also not how your Tylenol is made. It's not how your aspirin is made. It's not how your antibiotics are made. You can't just throw two things together. You got to know how much. That's what stoichiometry tells us. It tells us, it allows us to predict how much I'm going to get or how much I'm going to need to make a product. Okay? It predicts the amount of products formed or the amount of the reactants you would need to make a particular thing in a particular reaction. Which is why I make such good meth. And why Berwick is pretty much the meth capital of northeastern Pennsylvania. I just got to get my black hat and sunglasses, and I would be Walter. What's his name? White. Walter White, yes. Just kidding for the cameras. Don't really make meth. Although I wasn't kidding about Berwick being the meth capital of the world, but pretty much is.
Are you going to put that in?
2 on my street! 2! One blew up 2 years ago.
Wait, which street do you live on?
Yeah, just one. Yeah.
Where do you live?
Oh, I ain't telling you. The feds are after me the way it is. Just kidding.
Every street.
All right. What was that? What?
Oh no, Trent said to
Look up every other
look
island.
up like what.
Oh, every
where
island?
they-
And see which one smells like meth's being cooked? That's not going to be my
on my
house.
street too. Don't worry.
I know. Seriously, there's been 2 on my street, but that's...
Would they hear you?
Yeah, they're like a block away, one of them. All right, anyway, enough of the meth. But seriously, you do have to know how much to add. Otherwise, if I don't know how much to add, if I don't know how much is going to be made, there's a couple of things that are going to happen. One, I'll have leftover reactants that you'll be eating along with your pill. Okay, that's bad. You'll get you sick. Number 2, I'll be wasting money by buying too much or too little and not being able to make the product efficiently or economically for a company if I'm working for them. So I have to be able to predict these things. Now, you can predict what's made. If I tell you sodium chloride breaking up, what's sodium chloride? What's salt going to break up into? You can all tell me what's going to be.
Sodium chloride?
Sodium and chlorine, right. All right, and you can balance that equation. But now I'm going to teach you how to predict how much you're going to get from this. So here's the question, my first question. By the way, it's a very short chapter, probably the shortest chapter we're going to ever have. We could have the test by this Friday because I'm going to teach you how to do one thing in this chapter and one thing only. stoichiometry problems. Now, they are varied. There are some really easy ones, like this first one I'm going to show you with salt and using moles. And then there are some more difficult ones. But for the most part, you will not learn anything beyond what I'm pretty much the basis of which I'm going to give you right now today. The basis of which I'm going to give you today. We're just going to have to, we're going to expand on it. We're going to add little things here and there and make the problems harder. And you'll see how. You'll tell me how I can make the problems harder. Now, if I gave you that equation, and if I gave the whole thing to you balanced like that, no one would have trouble balancing that, I'm assuming, right? That's a pretty easy one.
I don't know, it was pretty tough for me.
No, it wasn't. The average on the last test, I told you, was in the 90s for both classes. I think like 94 for one class, 96 for the other. And there were a lot of hundreds. No one had trouble. And all I did in the last test was I gave you, everything. I gave you only sodium chloride yields, and you had to fill in everything else. Okay, you could do that. Now I'm going to start with that. That's the first step. Now, say I told you you had 2 moles of salt.
We make that chart.
Write that. You don't have to make a chart. You can just put a line here and a line there. That's all you got to do, because you already have these lines here. So just put a line straight down and a line straight down there. If I told you I gave you, here's a bag of salt. I told you there's 2 moles of salt in there. Go back in the lab. Break it up into sodium and chlorine. Let me ask you something. How much sodium do you think you'd get from 2 moles of salt? Think. What do you think? I'm not going to tell you. I'm going to do the first 3 without telling you how you got the answers. You're going to get the right answer eventually. Just guess if you don't have no idea, but you should have some idea. 2. Okay, she's right. 2 moles of sodium I would get from 2 moles of salt. How much chlorine do you think I'd get from 2 moles of salt? No, not 2.
1.
1 is correct. Don't know why? Hold on. You will in a minute. Let's go and do another one. Let's say I said, here's a bag. This bag's got 4 moles of salt in it. Go back in the lab, break it up into sodium and chlorine. How much sodium do you think I'm going to get from 4 moles of salt? Bo? 4. Everybody agree? And how much chlorine do you think I'm going to get from 4 moles of salt?
2.
Exactly. Getting the hang of it? If not, it's okay. You will. After this one, I told you I'm going to do 3 of them. This last one, then I'll explain if you don't quite get it. Last one. Bet you can figure this one out yourself. Fill in the rest of those. If I gave you 1 mole of salt, how much sodium, how much chlorine would I get from it? Figure it out yourself. Write them down to yourself. My guess is most of you know what their answers are going to be. If you don't, I'll explain it in a minute. Okay. Did you all write down 1 and 0.5? Hopefully you did. And if you didn't, even if you did, I want to explain it to you. Watch. Now, these numbers here, these coefficients, which is a 1 implied there, right? You all know that. Okay. These coefficients are the mole ratio. I said that way back when I first taught it to you, but I really didn't stress it at all. I probably said it 1 time in the entire chapter because it wasn't important at the time. Just like when you do your homework tonight, there's going to be little S's and little G's and little AQs and other things next to your thing. I'm not going to talk about that today. There's little letters that they stand for what state they're in, and we're going to deal with that when we deal with it, which will be in a couple of months. For now, you can ignore the S and the G and the L and the AQ. You can probably tell them what they probably stand for. What do you think S, L, and G probably stand for? Solid, liquid, and gas. That's right. But it means nothing as far as you're concerned with these problems. Right now. It will, but not right now. So, again, these numbers, these coefficients, tell you the ratio, the mole ratio of salt to sodium to chlorine. Look here. There will always be twice as much NaCl as there is of Cl2 you can get from that. It'll always be a 2-to-2 ratio, which is basically a 1-to-1 ratio, right, between salt and sodium. The coefficients tell us that. So if I told you you have 4 moles of this, and that's a 2. 2 is to 2 as 4 is to 4, right? It's a simple ratio. 2 is to 1, half as much, as 4 is to 2. Simple ratio. What if I did one backwards? What if I did, I gave you 4. Hit the wrong button. What if I gave you 4.0 moles down here and asked you to fill the other guys in? Could you do it backwards? Sure. What would you have to do there? If I gave you 4 moles of this, in other words, here's what I'm really saying. And this is kind of more of how a chemist has to think sometimes anyway, a pharmacist. He has to think to himself, okay, my job is to make, my boss comes in and says, all right, today you got to make me 4 moles of chlorine gas. And here's your sodium chloride. Here's a big bag of salt. How much should I get out of that big bag of salt? How many moles of salt should I get out of there? Exactly. And what will my byproduct be in that reaction? How much sodium will I get? 8. All right. Now, granted, by the way, if you're wondering, that's not how we make. This is not something you do on an industrial basis. We're not going to make our chlorine and our sodium by breaking up salt. I'm not saying maybe some people do. I don't know. I'm just saying that's what you would do. Most of the time, they're much more complicated reactions, multiple steps of reactions. But just so you know, that's the logic behind it. You could tell how much you need or how much you'll get by the coefficients of these guys. Simple as that. Let's try another chart and see how. Because this is what, by the way, you're going to probably get this tomorrow because you only have a single. I had a double yesterday. They were able to get some of this done. You're going to get a chart just like this on every worksheet I give you in this chapter. All right. Let's try another chart. Oh, before I do, how can I? Can somebody? I told you I'd ask you this. How can I make this problem more difficult? What are several things I could do to make it more difficult? What's that? I could have I could have a harder equation. Yeah, harder coefficients. What's that? Exactly. The numbers could be uglier. 1.7439 moles. Yeah, those are the 3 things I'm going to do in the next one. Okay. I won't finish it this time. I'm only giving you the equation, and I want you to finish it and to balance it. So you have a little bit more work to do, right? So do that. Sodium chlorate yields sodium chloride plus oxygen. Now, you know what to do, right? You've done this before. You have your common ion sheet? Go get it. If you don't, get it out. You need to look up sodium's charge, chlorate's charge, write them correctly. Remember who's diatomic. The whole 9 yards. It's the one that you got a very good grade on in the last test.
We're going to get those back now. Like you're going to show us the grades.
I already gave them grades on Friday. Gave everybody their grades. Oh, you were here on Friday? I thought you were.
I was singing.
Oh, well, I'll give it to you.
Okay.
You can all look these charges up. You could all write sodium chloride correctly, I'll bet you, by now. You all hopefully remember that oxygen is one of the diatomic elements, so it's O2. And hopefully you can all balance this. Who's not balanced in there? Oxygen. I've got 3 O's here. I've got 2 O's there. So I'll put a 3 there and a 2 there. That messes up my sodiums and chlorine, so I put a 2 there. And there it is. Now, notice that I had more to do. I had to complete the equation. I had to balance the equation. Secondly, my coefficients are not going to be quite as easy this time. You'll see in a minute. It'll not just be 2 to 1 or 1 to 2. All right? And eventually I'm going to give you some uglier numbers. So let's do this. Let's do this first one. Say I gave you 4 moles of sodium chloride. I asked you to decompose it. This is something we absolutely could do. You could decompose sodium chloride, and you could get oxygen out of it. Okay? How much salt would I get out of it? How much sodium chloride would I get?
4.
I heard 2. Which is right? 4. Because 2 is to 2. Look in here. Look, everybody's looking here. 2 is to 2. They're the same. So if I have 4 moles, I'm going to get 4 moles. These numbers, these columns, I don't care how many numbers I put down this side, this column is going to be exactly the same as that number, right?
Oh, really?
Absolutely. Why? Because 2 is to 2 as 4 is to 4. If this were a 3, this would be a 3. It's as simple as that. It's a ratio.
Oh, you mean just in this problem, not in all.
In every problem, in any problem, you go by if they have the same coefficients, they're going to have the same numbers.
Yeah. Okay. I understand.
Did you really think I meant that the first and the second one are always going to be
Yeah,
identical?
that's really what I
Really?
Yeah.
Mhm.
That's what you made it sound like.
You're right. That's what I made it sound like. Anyway.
14 changes.
Okay. Now notice this one is a little bit harder. Most of you could probably figure this out on your own, in your head. But some people probably can't. Either way, I'm going to show you how to do it the long way in a minute. 2 is to 3 as 4 is to what?
6.
6. I think most of you could probably see that in your head, but that's not good enough. You can see right away why it's not good enough to just be able to do these in your head. That's a nice, easy number again. 4, 2, okay? 2 to 3 is not that bad of a coefficient. What if I had 3 to 7 or something worse than that? So there's a reason we have to learn how to do these by a different method. And I'm going to show you that with this next example. But most of you can see that, right? 2 is to 3 as 4 is to 6. That's the logic behind it. So this one and the previous 4 are all just illustrating the common sense approach. Now, it's time to get the actual mathematical approach and how we're going to do these in a real problem, because they're not going to stay this easy. So let's start with this next example. Notice the number is uglier. The ratio is relatively ugly. Can't probably do this one in my head. Most of you probably can't. Better have a system. So I'm going to show it to you. Okay? Well, there's one I could do in my head. What's that guy going to be? Everybody agree?
Yeah.
That guy's going to be 0.378 because that coefficient and this coefficient are the same. However, this guy is a 3. Doing that in my head, not so easy. What do I do? Well, you do something you learned how to do in the first chapter with me. Conversion factors. We could do this by a conversion factor. If I said you had 0.378 moles of sodium chlorate, and I said to convert that to grams, you could do that, right? Convert it to atoms, you could do that. Molecules, you could do that, right? You can also convert it to how many moles of oxygen. And here, what's the first step in any of those? If I wanted you to convert something for the metric conversions even, what's the first step? What do we write down first? Yeah, skip yourself because there's going to be one more here. Skip yourself at least one line maybe before you write this down. 0.378 moles is my given information of NaClO3. And yes, you do have to write out the moles of NaClO3 first with it. In the past, I haven't really cared if you wrote out what it was because there was only one thing we were talking about at the time. But take a look up here. There are 3 things up there. I will get them confused if I don't write out moles of what I'm talking about. Next. What units have to go on the bottom? On the bottom. What units, though? Moles of NaClO3. Everybody agree? Because that has to cancel. Everybody agree? And what units are going to go on the top? What am I looking for? Is this blank thing right here? What do I want in there? I want moles of oxygen. Good. Now, here's the problem. We have seen these before. But when we saw them before, what did we always put next to moles?
1.
1. Am I going to put 1 next to moles here in both of these cases? If I do, I'll always get the exact same answer. What is it I will put next to these? The coefficients. That's the ratio. That's how they're related. 2 moles of this gives you 3 moles of that. That's the equivalency. So the coefficient of oxygen is, look here, everybody's looking here. The coefficient of oxygen is a 3, so I put a 3 next to oxygen. The coefficient of the NaClO3 is a 2, so I put a 2 next to him. And then I multiply those out and divide those out on my calculator. Who are they for?
Sorry, I was just trying to sneak in. Sneakers.
Oh, please for somebody? Oh, no.
What is that crap?
You're on TV, just so you know, Phillips. I'm taping this for the
Why?
for the world.
I need to know this.
Apparently not English teachers. Do that on your calculator. What do you get?
He wants to be a celebrity,
Some
like
letters
me.
and some
Yeah. Emily's always trying to get her face on here. Not going to work. Hey, I hope you have a good. I'll talk to you later. You be around 8th period? All right.
Yeah, that sounds like a date. Is there
Yep.
food involved?
It's a bromance. Point what?
5, 6, 7.
Did anybody else get that? 0.567?
Yeah.
All right,
sure.
and that's moles of oxygen. Sure. Beautiful. So that 0.567 goes up there. Good. All right, now, the thing is, I'm going to put a big red circle around this. I think it's going to be red in the future. I'm not sure. Pretty much every problem you do in this chapter must have that step in. Either implied by doing it in your head. Somebody say, well, didn't we just do this one and this one and this one? We did all those without writing out this stuff. No, but you did it in your head, you see. Would this have worked? Would this method have worked to do this one? Sure. You would have written down 4 moles of sodium chlorate, right? And then you would have had sodium chlorate on the bottom and salt at the top. What would have been both of the coefficients? 2 on the bottom and 2 on the top, which is why you get the same answer again, you see? And would it have worked for this guy? Absolutely. It works for all of them. Now, here's the thing. I did not make you write out every one of these. I'm not making you write out every one of these on the sheet. The ones that are harder, I left room for you to show work for me here. If they're simply a 2-to-2 ratio and I say this guy's 5, what's that guy going to be?
5.
And you don't have to write it out. You don't have to show me the work like this. Let's do one more. One more. You ready? Say I gave you 4.2 moles of oxygen. Could you work that guy?
No.
Sure you could. I have faith in you. Go ahead. Set it up. Do it. You know what to do. You know, the nice part about using a system we are very familiar with is even if you're a little confused at the beginning of this chapter, you know how to start this. What are you all writing down now to start your conversion? Yeah, which is what? 4.2 moles of oxygen. And that starts you off. And then you kind of think to yourself, okay, well, I know it's got to go on the bottom. And then I think, okay, what am I looking for on the top? And then I think back, okay, the only new thing is the coefficients. And you're done. And you've done it.
Yeah. Everything else. Salt.
Feels like
Now, look up here. You all have moles of oxygen on the bottom, right? And moles of, it doesn't really, does it really matter who I go to? No, because they're both going to be the same. Moles of NaCl on the top I'll go to. What's the coefficient of the NaCl? And what's the denominator going to be?
3.
Exactly. Notice this time it was 2/3. Last time it was 3/2 because it depends on where your things are. Depends on who's down here and who's on top. Moles of oxygen cancels out, leaves you with, what'd you get? 2.8? Everybody get that? If this guy's 2.8,
Then that guy.
then that guy is 2.8.
Alright, I have a question.
Yeah.
What if, or there's never going to be a situation when it's not going to have, like, you know how it says like 2 NaClO3, 2 NaCl? There's never going to be a situation when it's like 2 NaClO3, 4 NaCl.
Sure. I mean, because the next one could be, if this were 2 to 4 to 3, yeah, absolutely. It could be 1 to 7 to 9. It could be any numbers you come up with. It would never be 2 to 4 to 2, because what would that do? Reduce to 1 to 2 to 1, you see? But it could be any number here, and any number there, and any number there, depending on the equation.
So, if it would be like 1 to 7 to 9, we'd have to do this twice.
No. 1 to 7 to 9, just throw those numbers in there. I got 1, if I would ever, 4 moles of this, and write 4.0 moles of, we'll call it, sodium chlorate, right? NaClO3 times NaCl, it's got 7, right? Moles of NaCl. So I put moles of sodium chlorate on the bottom, moles of NaCl on the top. He's got a 7. He's got a 1.
And then for 9, we just change it to 9.
Yeah, I would do a separate conversion, and I go from this guy to 9. It would be 1 on the bottom and 9 on the top. That's all. Okay, now, time for, and I want you all to write this down. I have time for one more example, but it's much more like, these here are going to be about 10 to 15% of the chapter test, okay? On any given worksheet, notice at the top I'll have one of these chart kind of things, but they're awfully easy, okay? I'm going to start giving you them in the way the book gives them and the rest of the ways I asked them on the test, which is it's a word problem. So copy this example down.
Do you have a pencil?
Don't have it. Oh, wait, somebody left one here.
Ah.
It's right there. There's a left pencil in there, so no.
Okay. Don't hit my camera. Bad enough I had Phillips in here. Don't hit it. I'll stab you in the eye with a toothpick.
Ooh, that's tempting.
Oh,
I don't think a toothpick would do much.
You can try. Yeah, challenge accepted.
Wow, this is a perfect pencil. Should we get those pencils that are just perfect in every way, shape, and form?
Practically perfect in every way.
I feel bathroom. Why? Oh my God.
You realize you're speaking now, Emily. People can hear you.
Yeah.
What?
All right, now stop. Everybody stop and take a look up there at this problem. Did we go with that?
There's not a question mark.
No.
There's no question. You're right. There's no question mark. So you couldn't possibly understand what it said.
Nope.
It's technically not asking.
What is this
anything.
one from me?
All right, take a look. This is what happens when I do. This problem's no harder. As a matter of fact, it's actually a little bit easier than the previous one I just did. However, putting it into a word problem, I just saw this over the weekend. Just saw that on my Facebook. There was this meme. I thought this was pretty good. Turn that light off for a second. I see math word problems. How I see math word problems.
Yes, exactly.
I saw that.
That is how most of you see word problems.
Pretty much.
If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. That's the kind of answers I get. I get the purple alien wearing hats from you guys all the time. Hit that light back on.
Just that aliens
Now,
don't
They
wear
don't wear
Whatever. Because aliens don't wear hats. Non-wearing hat alien people. Look at the thing is, by the way, notice she's a female. Emily.
Whoa!
Emily.
That's
Kind of looks like
that's
Emily.
really mean.
If you cut your hair short, that would that not be Emily right there? I just made that up. Look, that's it. Look right there. That's her. Look at it. That is exactly like her. You cut her hair.
Wait, let's do the hands.
Now she has a reason to cut her hair. Okay, now it.
No?
All right. Oh, wait, back. Here, back to this one. Now here's the problem with this. This is what you guys do. You get a word problem and you try to do it all at once in your head. You know, a train travels for 20 minutes at 40 miles per hour, due east, then it goes north at 5 minutes for 30 miles an hour, and then it goes west, and then they ask you what the price of tea in China is, and you have no idea. All right? And the same as with the purple aliens. You can't do the problem all in your head at once. This is one of the reasons I've been trying to teach you how to show work and to divide a problem up into steps. Let's divide this guy up into steps. I'm actually going to read this word problem at least, minimum, every time I do one. Minimum, 3 times. Minimum. The first time I read it, all I care about is finding what words tell me about the equation. I want to know what the correct balanced equation is. Now, everybody look up there, and I'm going to ask you a very difficult question. I'm going to underline in black what words tell me all I need to know about the equation. And they are minimal. Just a minimal number of words that tell me about this equation. to write down the first step, which is only the first step is only writing the equation. That's all I care about in this first step. So tell me, what will I underline in black? I'm going to use 3 different colors. What am I going to underline in black? What tells me about the equation? What do you think, Emily?
Carbon dioxide?
Absolutely not. Completely useless. Do not need the word carbon dioxide at all.
Aluminum carbonate.
What about it? I need something else.
Yields.
Nope. No. The word yields isn't up there, but you may be on the right track. One more word.
Decomposition.
Stop. That's all you need to know. All I need to know is it's the decomposition of aluminum carbonate. And then I look on my common ion sheet, and I know what aluminum carbonate is going to break up into.
How do you know that?
Look on your common ion sheet. What does aluminum carbonate break up into? Take a look. Everybody look. You got to look now. What does aluminum carbonate break up into? Aluminum oxide plus carbon dioxide. Okay. I have to complete this step. This is all. Hey, by the way, this was your whole test before Christmas. It is now step 1 in this process. And I'm not done with it. Aluminum has a charge of +3. Carbonate has a charge of -2, so it's Al2CO33. Right? You would have done that back before Christmas. Nothing goes away in here. It's why the midterm we're going to take this year, in a couple of weeks, is going to be easy. You won't really have to study for it. Al +3, O -2, 2, and 3. And carbon dioxide, CO2. Everybody knows that. Got it? Is this guy balanced? What do I need to balance him? Got 2 aluminums. I got 2 aluminums. He's okay. I got 3 carbons. Uh-oh. We'll put a 3 there. Are we okay now? Yes, we are. Because 3 times 2 is 6 oxygens, and 3 more is 9. 6 and 3 is 9. 3 times 3 is 9. I have 9 on both sides. I have now completed the first step.
Yay.
Now, look at guys. When I go back up here, the first time I read it, all I cared about was decomposition of aluminum carbonate. I could care less about any other stuff. Somebody in their class said 0.896 moles. Made no difference. Somebody else in this class said carbon dioxide. Someone else said how many moles. No, none of that was important. Now, the second time I look back up here, I'm going to use red. What will I circle in red that tells me how to begin my conversions? What should I circle in red that tells me how to begin my conversions? 0.869 moles of aluminum carbonate. I have to say of what? Of aluminum carbonate. So I'll do that in red. .869 moles. Multiply by what units have to go on the bottom? I don't have to look back up for this. What has to go on the bottom?
Carbonate.
Moles of aluminum carbonate. And I'm going to change colors again. I'm like a chameleon. Chameleon. Boy George, what an actor. Well, wasn't an actor, I guess he was a singer. Okay. I look up the third time. I told you there's a bare minimum of 3 times. Okay? Third time, I have to look up to find out who it is I'm trying to find. Who am I trying to find?
Moles of carbon dioxide.
Carbon dioxide. There he is. So carbon dioxide is going to be on the top. And what? What kind of units? What do I have to go to since these coefficients here are mole ratios? I got to go to moles of carbon dioxide. Because that's what, after all, in order to use the coefficients, it's got to be in moles. And if you may remember a second ago, I told you when I circled in red that one, that step has to be there, and there it is. Moles of what you have to moles of what you're looking for. Has to be there to do stoichiometry. How do I finish it, though? What goes on the top? What's the coefficient on the top going to be? 3. And the coefficient on the bottom?
1.
A 1. Coefficient of aluminum carbonate is a 1. Coefficient of carbon dioxide is a 3. There it is. Now I'll just go back to black to get the final answer. What's my final answer in this problem? Do the math. What'd you get?
2 2.607 moles of carbon.
2.61 then for significant figures, because he's got 3. Do these guys limit your significant figures? No, they're exact numbers. Okay, moles of CO2. This step, people, has to be there. Moles of what you have to moles of what you're looking for has to be there, or you didn't do stoichiometry. Now, I'm not going to do it now, but I'm going to ask you now. What's another way I could make this harder? Besides the numbers being uglier, besides it being a word problem, besides the coefficients being harder, and besides having to fill in all the equation, there's something else I can do that I'm going to do tomorrow. What?
Negative.
No.
Instead of moles, it could be like molecules.
Molecules, grams, atoms. Yes. If instead of saying how many moles, they said how many grams. And worse than that, we won't do that probably tomorrow. What if instead of giving you 0.869 moles, I gave you 0.869 milliliters or grams or molecules or atoms? Yes, you're going to have these kind that you could do not just one conversion, but 2, 3, 4, 5 versions in order
So
to
I
get
should
the
commit suicide tomorrow.
So yes, get the gun ready.
Oh.
Which you will not need.
No, it's the
It is not that bad.